Hey there, YouTubers! If you're just joining us, we're about to watch the launch of a Block 5 Falcon 9 rocket. We're currently at T-minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And the Falcon 9 has launched! We have liftoff! Woo! Hi there, Dr. Sheep here. Welcome to another physics video. Today we're talking about rockets. Now, we talked about rockets before in this channel, so as to how they specifically work, physics-wise, I'm not going to really talk about that. I'm going to really talk about the kind of the history and the evolution of rockets, and the two main types of chemical rockets. So here's a rocket launch now. So I'm about to assemble a baking soda rocket that I spent 12 bucks on it. It took about 2 seconds to assemble. Worst part was pouring the baking soda into the launch pad. Now yes, I'm inside, but it's currently sleeting. So yeah, let's just oh, wait. It says 50 feet. We'll find out. Oh my gosh! That was the biggest waste of anything ever. Now that rocket you just saw was just basically a pressure vessel with a hole poked in it. And I've explored those kinds of rockets before in my Newton's second law video, where I actually explain how rockets work in general. Today we're exploring the two specific types of chemical rockets, solid and liquid. So we're going to start with solid rockets, because they were the very first rockets to ever be developed. Now these early rockets were not really meant to be reused. They were meant as fireworks, as you can see in this video. Now yes, if the thing hadn't exploded, maybe it would be reusable. I mean, even with it exploding, here's what was left of that skit with the fake Falcon 9. I mean, you had the nose cone left, and the fins are somewhere, I think. So I mean, yeah, it could be reusable, but generally they're not. But why? Well, to explain why, we have to explain how a solid rocket booster works. And I keep saying booster, because that's generally what they're used as. You would never use a solid rocket as a fully functional rocket. Again, it'll make more sense once I explain. So, in a solid rocket booster, there is a mass of fuel and oxidizer. Now, without the oxidizer, the fuel would not light. You need oxygen, and the oxidizer provides the oxygen. Now, at the very back of the booster, you have an igniter. This adds energy in a form of heat to the oxidizer and fuel. This kick-starts the chain reaction, which quickly burns through the mass of fuel and oxidizer. And this reaction can't really be stopped at all. And so it just burns. And this nose cone at the back can't really be, the direction really can't be changed because, well, it's fixed. I mean, because the fuel and the gas and the oxygen, it's all being poured out the back. You can't change that. So what you point these in a direction, and that's the direction it's going in until it runs out of fuel and oxidizer. That's it. It's going to keep going. Well, that reaction scars and chars the inside. That's going to require tons of cleaning and just may just require a whole replacement of the inside of the rocket. That's way too expensive, and the thing's going to fall into the ocean anyways, or crash into the land, and it's going to just get basically destroyed anyways. That's why they're not reused. Now, on smaller scales, yes, you can reuse them, kind of. And that's why they're used as rocket boosters. They provide tons of thrust, more than most liquid fuels can. But that thrust is only unidirectional. You can't change the direction, you can't turn it off. So, can you reuse this? So that's why you can't reuse it, and that's why they only use as boosters. Now, on a small scale, yes, you can reuse it, as you can see over here. Let's watch that video now. Alright, on 3, 2, 1. Wow, wasn't that exciting? I actually have no idea how that rocket launch went. Here's the rocket the day before. That's tomorrow morning's plan. Hopefully, anyways. Here's an extra motor I just about broke. It's still intact, still good. So if everything goes the way it should have, that rocket will return back to Earth nice and easy. I'll pull out the old charred motor and put this new one in. That's why it's not really reusable. That whole thing is. But this part, which is the key, most important part, isn't. Liquid-fueled rockets changed the game and fixed that problem. Here's why. So in a liquid-fueled rocket, you have two tanks, oxidizer and fuel. The oxidizer is always liquid oxygen. The very first liquid rockets used liquid oxygen. Then you have some sort of fuel. I have liquid hydrogen here. You could use anything really. Kerosene, gasoline, methane, which is what SpaceX is going to use in their newest rockets coming up. And you could use really any sort of high energy fuel. Anyways, the oxygen flows through this tube around the hydrogen to this part down here, where it's precisely mixed with the hydrogen at specific ratios, ignited and fired out the back end. And this back end is very unique because it can move, it can gimbal, and it changes directions. It means this rocket, it can be steered, which is why it is ideal for getting things into orbit. And the only part that gets charred is this back end. Otherwise, this whole front end, provided it survives re-entry, is fine. Perfectly fine. It can be refueled and reused over and over and over and over and over. It's beautiful and nearly perfect and so simple. Why, hello there. I have my fun fact book. I'm in my fun fact chair. So therefore it's time for a fun fact. Today's fun fact about rockets is that the early rockets, their first fuels were gasoline. But the Nazis, their first rockets, which were like the second liquid-fueled rockets of ever, used ethanol. And scientists reported that when they opened the 50-gallon barrels of ethanol, that they seemed to evaporate faster than they originally expected. And that blindness was going rampant amongst the base. Coincidence or not, that blindness was due to alcohol. The soldiers were drinking the ethanol. Isn't that just fascinating? Well, here we are. We've reached the end of the video, the conclusion. Well, we've talked about pressure vessels with holes in them. We've talked about solid rockets, liquid rockets, the evolution of rockets, the pros and cons of solid and liquid, how liquid is far superior than solid. But something I didn't really talk about, and I try to do in this conclusion, is how significant these things are in our daily lives. Rockets have far more of an impact than you could ever realize. Your phone, computer, tablet all rely heavily on satellites that were placed into orbit around the Earth by rockets. Now, how do they stay in orbit? Well, that's another video for another day. But in the meantime, I'd like to thank you all for watching. Please like, comment, and share. New videos every other Friday. And good night. Step 3. Maybe I should consult my book. Oh, hi there. Didn't see you there. Bet you didn't see me because I know nobody's watching. Because I never want right now, like how to make money from YouTube. Yeah, you should totally subscribe, please, and check the playlist wherever it's gonna pop up. Geez, this is getting awkward. Bye.